Great. Good morning, and thank you, Tim and Oppenheimer, for the opportunity to present the great stuff we're doing over here at NextNav, which is solving a national security issue by strengthening the national positioning, navigation, and timing, which I will abbreviate to PNT, during this presentation. So if we can move on to the next slide, please. Just at a high level, let's talk about our investment highlights. We have great technology in commercial networks, and we're evolving it to be a next generation PNT solution that is embedded in 5G. We have valuable spectrum assets. We'll talk about them a little bit more later, which have great propagation characteristics to enable this PNT and also broadband 5G. We have a great management team, board and shareholders. Management and board are previous telco spectrum technology evangelists commercializing innovation, and we also have leaders in our national security and location services. We have great customers and partners. It's not a full list, but it includes AT&T, Verizon, and NASA. We have a robust balance sheet, and we have great liquidity to fund our operations. Let's move on to the next slide. So let's talk about the problem statement about why terrestrial GPS complement and backup is needed. Many of you use GPS on a daily basis. Besides using it for navigation, GPS also is used in our telecommunications, power grids, water supply, financial transaction, and many other critical infrastructure. The problem statement is the satellite-based systems, which GPS is one, they have coverage limitations in urban canyons and indoors, and also they're very vulnerable to spoofing and jamming, either by rogue actors or unintentional interference, and also they're susceptible to disruptions, such as when natural phenomena like solar flares happen. To the right of the screen, this is a lot of the quotes that we've picked about national security leading experts, DoD experts, that talk about how this is a major problem for our country and how a single point of failure is an issue. Also, how you can very cheaply, this is a DoD quote from Tom Rondeau, you can, with $300, jam GPS, off-the-shelf equipment. So the problem statement is real, it's there, and we would like to provide the solution, be a part of the solution for it by providing a terrestrial GPS and complement and backup, which is going to address the satellite vulnerabilities. Let's move on to the next slide. So our PNT vision is that we're going to leverage our spectrum assets in the lower 900 megahertz band. We're going to build a PNT network that's embedded in 5G NR, aligned with 3GPP global standards in devices commercially, leveraging economies of scale. Our goal is to create a future-proof complement and backup to GPS that is wide scale and also is available indoor and in urban canyons. Let's go on to the next slide. Our solution is really very simple. The problem statement is that we need a backup that is a system of systems. We are a part of the solution, and that part is a terrestrial component. The issue with why this hasn't been done before is because building a terrestrial network that is wide scale and covers a terrestrial footprint is extremely costly to compete with a free service, which is GPS. So what we're proposing is that we're going to use our lower 900 megahertz licenses. We're going to partner with a 5G network operator to then use the spectrum for 5G, but take a sliver off of the top of it to provide the PNT, which is the terrestrial backup and complement to GPS. And we do all of this without taxpayer funding. So we don't need any funding from the government. Let's move on to the next slide. Let's talk about our spectrum a little bit. The lower 900 megahertz, and you see to the left is a map of the United States. We hold the rights to licenses covering over 96% of the US population. We have the rights to approximately 4 billion megahertz pops in the lower 900 megahertz. And we'll talk about what we're doing to optimize the band plan and optimize the spectrum. But what this optimized band plan is going to do is going to attract and retain high-value subscribers, similar to public safety, who are also be served by PNT. The total value of this GPS complement and backup to a Brattle report that we have a slide on is $14.6 billion, the $14.6 billion insurance that we're providing. And basically, this is all done on amazing low band, very great propagation spectrum. All spectrum is equal when you go to low band, such as 900 megahertz, and spectrum below 1 gigahertz specifically has the ability to go and penetrate walls and serve the urban canyons really well. And in addition to all of this, we're going to also not only solve the PNT issue, but also be a part of the solution for the PNT issue, but we have 10 megahertz of downlink for broadband data, which is significant bandwidth in low band. Again, not to compare to C-band or any of the high band spectrum, which is more capacity spectrum, low band will remain as the only solution for coverage spectrum. Let's move on to the next slide. So what have we done in this past year and a half, a little over a year? Currently, the band plan that we have licenses in is in this first chart. It's called the MLMS spectrum. There's an A block, there's a B and a C block. And these were intended to provide multilateration, location, and monitoring services. And what we have proposed is the band plan below, and this is what our FCC petition would be, to say, let's optimize the band plan, let's create contiguous blocks of 10 megahertz plus a 5 megahertz uplink for 5G, such that it will be attractive for a nationwide operator or other partners to build using 5G. And we could then enable PNT that is within the 5G standards. This is what we have proposed to the FCC to optimize, to solve not only a national security concern, but also to put more spectrum, low band spectrum, to address the coverage gaps that I think we'll still face, no matter which operator you use today. Let's move on to the next slide. Let's talk about our PNT architecture, because you've heard me say that this 5G is embedded in, the PNT is embedded in 5G. It really is a signaling that's part of the 3GPP standards that you need to turn on to provide these beacons that we can then multilaterate on to provide positioning and timing. This network will seamlessly and then after this beacon is turned on, we will put our software on top of that and extract the positioning and timing. This seamlessly integrates into the 5G networks with just software solutions sitting on top of what any carrier deploys today for 5G. We will leverage the 5G partners' network facilities, so we don't need to build a network. They will add spectrum to their towers, just like they add any new spectrum, just like they will do that all the time, because they're not going to be able to not expand their spectrum footprint as population capacity and coverage demand increases. The build out of this network, or what's known as a topology, will be just like 5G networks. We don't need to build additional towers. This will facilitate partnerships with existing providers and enable us to leverage their existing deployment. So to the right is a picture of what the architecture would look like and how we will take this very thin sliver of capacity, so not spectrum. So they will deploy the 10+5 like a 5G network, and we'll take a sliver of their capacity, the data, because you turn on the beacon, that will get used, and then we'll have our software extracting this to positioning and timing and navigation ultimately. Let's go on to the next slide. So this is what I was talking about. The Brattle Group last year did an amazing economic report that quantified the value we bring by having a terrestrial backup to GPS. And again, this is a critical point with no taxpayer funding. There's a lot of solutions out there that for a very long time, some of them for decades, have not been able to deploy because, again, the economics to compete with GPS are not great. So they've requested government funding to solve this national security issue. We do this, we provide this $14.6 billion of insurance without any taxpayer funding. And the economic report highlights what would it look like if we were to not have GPS. On the left-hand side, a one-day outage would have a $1.6 billion economic loss. 7-day, 12 billion, 30-day, 58 billion. This is very significant. So we will prevent this economic loss, and we will be a part of the system of systems that enables this insurance plan that we're providing for critical infrastructure and also consumer use of PNT. Let's move on to the next slide. This is this is a lot of activities just to show you what we've been doing starting in April of 2024. Of course, immediately after our acquisition of A block licenses, if you saw on that spectrum chart, we had the B and C block. We acquired the A block from Telesaurus. Immediately after that, we filed a petition at the FCC that proposes to reband and proposes to optimize the spectrum for 5G. The FCC issued a public notice in the previous administration. We filed comments. Others also filed in that docket. And then there was an administration change, and the new administration came in, particularly Chairman Carr, and he put a lot of focus on solving this problem holistically. And we were mentioned in his what is called a notice of inquiry by the FCC. And that when it came out this year in April, we filed comments, and again, other industry members filed comments, as well as some in opposition, some in support. Opposers are people who are in the band and don't want a status quo. They want to remain with the status quo. They don't want to change. And people who are supporting are primarily public safety, but also a lot of the other filers mentioned how a market-based solution is really important. And they supported the NextNav petition. Since then, after the NOI, we've also filed several very critical studies to show that the existing operations in the band, which are consisting of, the active filers consisting of licensed operations and unlicensed operations, how there will be no impact to unlicensed, and with licensed tolling operations, the impact and the retuning they would need to do from that shift I showed you on that chart is very minimal. So it's very feasible, and therefore we believe that the FCC can move on to the next stage of what is known as a notice of proposed rulemaking, which then seeks comments once more to be able to finally adopt a rulemaking. Our studies solve the economic problem, solve the technical issues, And we are in a great place and a very, very urgent timeline, as is demonstrated in this, and how fast things have moved for us. I believe that must be the last slide, if I'm not mistaken. Yes. And that wraps it up, and look forward to Tim's questions and the audience's questions.
Great job, Miriam. Thanks a lot for the presentation. Very comprehensive. So what is the next step in the FCC process? Yeah, and they've given an order granting the rebanding already, I believe. So what's that take to become, I guess, law or, permanent? Yeah.
So they've given an order to approve our assignment application, which included waiving certain rule that doesn't permit three blocks being held by a single licensee. That was a great thing, and we're very thankful to the FCC with all the timing and staffing resource issues that they've been having. The next process for the petition is really, and the NOI is really what's known as a notice of proposed rulemaking. So they will, or NPRM for short, they will issue an NPRM and seek comments again, and then study those and then determine what the final rule and report and order would be. So that's what we're looking forward to, and we're advocating very urgently with the FCC to move on to the next one after we've demonstrated that there should be no issues and there's no data demonstrating there's a problem.
Got it. So the primary issue is, would you interfere with existing use cases? And you filed some technical studies. Can you maybe detail, who is in opposition right now and what your technical studies, found?
Of course. The opposition in the license, and again, spectrum is licensed, meaning people pay for the usage, and then there's an unlicensed allocation, which is free for use, and license has priority over unlicensed always in every band. In the license category, the toll operators also operate in that band, and they have been opposing NextNav. And basically, what we have filed is a very comprehensive, detailed, validated, fact-based study that show that the tolls can coexist in that middle segment of the band with us with just very, very minimal retuning. And if for folks who are available, if are familiar with spectrum and other spectrum rebandings, a lot of the times when you impact an operation and they have to move, they have to take out equipment and put in new equipment. This is not the case in this band. This is really a software change to really shift because they are able to operate in the entire band down below. So that's one study we did with respect to the license operators. Then we also have provided a unlicensed study, and these folks, Tim, that you asked, are folks like this is not a Wi-Fi band that you use, and all of us are using Wi-Fi right now. This is more of an IoT band type application. So you're talking about very small bits of data that go from a smart meter or Echo Bee in your home reading your thermostat, or these kinds of operations that are very, they don't operate the whole day. They just send bits out and then they respond back. These folks will not have any impact because the existing licenses in the band already allow for a certain operation. And that operation, we're not changing that in any way that impacts the unlicensed operations. These folks can continue with their whatever equipment that they have in the IoT space. They can stay in the band. We're not asking them for them to relocate. And the technical study shows that the energy that we would have put out in our existing licenses is not changing when we go to the total energy of 5G. In fact, in part of the band, we're reducing the energy that we've been permitted to operate on because handsets require very low energy.
Very good. So have you actually performed trials yet, in certain locations and retuned, for example, the toll equipment so that, to prove this theory out?
We've worked with labs. We've worked with measurements And basically, that is a very key and important part. You take a toll reader and transponder, you take it to the lab, you measure, you simulate the outdoor environment. We've also proposed to put a network up. We already have an existing, by the way, network, and that network is in proximity to all of these operations and is transmitting, and we haven't heard a single complaint of interference. But we're changing that to 5G, and we will take this out on the field as well and show it and demonstrate it. But right now, the lab measurements and the paper analysis are enough to move to the next step, which is an NPRM, and there is no field study required of this stuff. The lack of data by the opposition, I think, just attests to that, because if there was a problem and we were wrong, they'd come out with tons of data showing why it's wrong, and that's non-existent.
And how long would it take you to kind of upgrade your trial network to 5G? And, how long of a proof period do you think would be good to kind of show that there, in real life, there is no interference? I know it's not required, but it seems like it would help the story. But
Yeah. Yeah, it really is not required for interference. For commercialization of the technology, we definitely have to have this up, and that's the primary goal while we have the live network up. Our current network, it operates really well, and we're evolving that to next generation to be based on 5G. We had a milestone earlier this year that actually did demonstrate that at the existing power levels on the field. Now what we're doing is going to the 5G power levels, and our goal is to finalize that by early next year, to be able to commercialize the technology. It is not for interference basis. We do not believe a field test is required for interference basis. That is our position right now.
got it. And very understood your position. But do you think? Have you gotten any soft feedback from the FCC? Do they agree with your position? Are they ready, do you think, to move forward with an NPRM, or would they kind of require more of a technical trial, a commercial trial?
I think the FCC would not come out and agree or disagree with anyone, right? Their process includes collecting comments, feedback from the industry to then make a decision on how to move forward. And that decision, sometimes, there'll be people who will be unhappy about it, and they'll make a decision. They'll definitely weigh the public interest as they have outlined. So that is a goal of the FCC. And they'll evaluate the impact and make a decision to go to the NPRM. They don't tell you ahead of time of their decision and what they're doing. But so far, every meeting that we've had, and this is all public, that's on the docket, this procedure is all public. Every meeting that we've had, we have had extremely positive exchanges with the FCC in terms of understanding our data, in terms of explaining what we have provided, and they've been very good meetings with very good questions.
And when did you initially file the application for the rebanding? How long has the process taken so far? Just remind me.
So we filed a petition April of last year.
Right.
The PN, the public notice, came out in August and concluded sometime in September, towards the end of the year. And then the NOI came out March of this year. Those are extremely speedy movement for the FCC. And the NOI came into the March of this year. They're looking at the comments that were filed within those notice of inquiry to then evaluate what their decision would be going to the NPRM. Our position is we should go to an NPRM. We should do it as fast as possible to solve this national security problem.
Okay. Any best guess on the timing of the NPRM, or you just can't predict it from the outside? Yeah.
It's going to be very hard to predict. It's their timing and their process, and right now they're dealing with very important issues. Chairman Carr put out a C-band NOI. There's the auction and the spectrum bill. There's a lot on their plate. We like the fact that we've also been prioritized, and we look forward to them treating us as a priority with all these other priorities that they have. So it's going to be their time. It's going to be their staff that is working with all of these important issues to determine how they get this to the next stage.
And to be clear, once they do issue the notice of proposed rulemaking, how long does the comment period usually last, and how long before that's finalized? Yeah.
I mean, the NOI comment period was 30 days and 15 days. There's normally one comment and then one reply comment. I can't tell what the NPRM comment period is going to be. They have ranges. Sometimes the C-band NOI was a 3-month comment period. I mean, we were a lot quicker and faster comment period on our NOI of Chairman Carr. So it's hard to tell. They'll weigh different things, but it could be anywhere from 30 to 15 or longer than that. 30 and 15 is very speedy.
So what you mean is, so the public has like 30 days or a few months to make comments,
Yep.
then there are reply comments. So that could be like a 2 or 3 cycle process, or usually like 2 cycle.
No, it could be, it would be more than that. So it's first a comment period that could be, let's say, 2 to 3 months. Then after that, they have to take the meetings, they have to talk to people, they have to review, people will go in, advocate for their positions, so they'll set aside time to discuss those comments. And then they'll move into, this is post NPRM since you asked, to determining writing the report in order. Writing these also takes time by the staff, right? They have to, they're very comprehensive. The way it works is they say, company A said this, company B said this, entity C said this, now we do this. It's a very intensive process. So it will take, it's months.
Okay. So the whole process, we don't know, but it could be another 1 to 2 years, essentially, from now.
I would like to, I'd like to remind the FCC of the urgency. While I can't comment on their time, but this is an urgent issue. So we're advocating and we'll continue to push that.
Got it. Okay, good. So it seems like a very, very high likelihood that this is going to be granted. The FCC has a policy, I believe they want to get as much spectrum into place as possible. They want to grow the economy. Obviously, this is a geopolitical issue on many, many fronts. So it seems highly, highly likely that it will be granted. So then the next step is, what do you do to maximize the value of the spectrum? And what do you do to kind of get it built out? Yeah. So, what do you think is the best way to build out the PNT once it's granted?
You said, sorry, and
we had a
glitch over there.
What will happen to the spectrum once it's granted? What do you think is the process? At that point, once it's granted, how would you build it out and how would you put it into use? Yeah.
How would we put the PNT into use?
Well, the spectrum. How would you build out the spectrum? Yeah.
I am operator, right? Which with a either wireless facilities infrastructure provider, and I want to make sure, am I cutting out because you were cutting out for me? You can hear me, right?
Yeah, I can hear you. Yeah, yeah.
Okay. By partnering with, most likely a 5G operator, but there could be other partnerships. They will build the network for 5G, not for PNT. We will then use that 5G network to enable PNT, and it will serve not only as a backup and complement, but also it could have value of commercial use cases. So partnership is our route.
Okay. And can you operate the PNT separate as a separate division within this build out, or was it most likely that the spectrum would get sold here?
It would be whatever that makes sense for the partner, and primarily our goal is to increase shareholder value. So we're going to look at what is best for our investors and decide how this model will look like. It's a little bit premature to say what it will look like, if it's a sale or lease or a revenue share, but all options are right now on the table, and we were going to pick the best option for us.
And do you need any upgrades to handsets or other equipment to basically be able to use the PNT? And I guess the same thing for the cellular networks. Yeah.
Not for the PNT, but for 5G, any new spectrum that any operator actually deploys, and they will continue to do this, will have to go into handsets and radios on towers. So it impacts both of them. It primarily impacts the radio. Some spectrum even need new antennas. We sit in a very sweet spot. So it's within existing spectrum, but when you go up in frequencies, you're going to even need a lot more changes, and you're going to need a lot more sites for C-band. But basically for low band, you really are deploying on top of what you would have at 700 megahertz or 800 megahertz or 600 megahertz. It's the same very close propagation characteristics. So you swap out the radios or add to the radios or combine radios. You do that on the towers. You also need to put new components in the handset or optimize them. Sometimes it's very complex, but this time, there's existing equipment and existing filters that cover this band. So it's a minimal change to the handset. This is part of a routine that any operator today does. They go to 3GPP standards, they get a band plan, they get the handset manufacturers to include it on a roadmap, the base station manufacturers to include it on the roadmap. It is not a complex issue to solve for an operator. Now, if you're somebody who has a very unique spectrum and doesn't have any economies of scale and you're not the big operators, yeah, sure, these things could be a challenge to get into the ecosystem. Apple's not gonna put your spectrum in because it's they do volumes. But when you're partnering with one of the operators, absolutely, for them, it's a roadmap discussion.
Right. And do they, new radios, do they have to put new antennas in also, or can they use existing ones?
I believe in this band, some of the operators definitely can use existing antennas. I mean, because of what they have currently on the towers.
Okay, that's really that's really helpful. And would your PNT take up much of the capacity? Where I guess the 10 megahertz of downlink? Yeah.
So the PNT takes about 2 to 5% of the capacity, not the megahertz. Megahertz is not split. This is a 5G network that's spewing energy, and it has signals that you turn on for this thing or that thing, and you turn it on for PNT in this case. When you turn on PNT, that requires a 2 to 5% capacity that's not available for the broadband users that are using data voice communications on 5G. So that's the impact to them. But our software, and going back to the next question, because our PNT solution is software based, it doesn't, that's not a handset tower or any other capacity impact.
So you'd have to upgrade. There'd have to be incremental software in the handsets and in any IoT devices.
Just like today, right now, our Z-Access solution has an app in the background of the handset. So it's not Apple like saying, because when you get the real estate with the phone is all about hardware limitations. If you're not adding hardware and your app in the background on software, that's a very different case. Yeah. So currently our Z-Access that's sitting in handsets for Verizon, that's operating in software. There's no impact to the handset or the network.
I often find in urban areas that the GPS is fairly inaccurate. Have you ever compared your accuracy in like these urban areas of your PNT versus GPS?
Yeah, absolutely. I mean, I wrote an article earlier this year in Forbes when I went to Mobile World Congress in Barcelona. I mean, it was a challenge. It was a big challenge finding places. So absolutely, we will solve that problem, which is a big commercial problem, not only in cities like Barcelona, but in New York City. You want to get an Uber. It's sometimes you're not able to find the position properly. We have tested it with existing technology, and we will test again with 5G technology when those towers are ready to go again early next year, but we're trying to beat that timeline.
So if one of the three big carriers were to basically partner with you, either buy you or license a spectrum, do you think they'd be able to market a more accurate PNT service to their customers as part of their overall service plans?
Yeah, absolutely. They could market a more accurate PNT service. They could leverage the fact that it would be a backup to critical infrastructure. And they could have newer commercial use cases coming out of it because the precision on timing and the positioning improvement in indoors is much needed in a lot of the commercial applications. Yeah, they could collectively either together or if they buy by themselves, they could absolutely leverage this.
I mean, I know it's hard to, but how accurate is your PNT in urban areas? Is it down to centimeters, meters? Yeah.
This is about, think about it as a coverage problem, right? So what happens is satellite, it hits a building and you're not seeing the signal, so you can't trilaterate, you get positioning off. The 900 megahertz spectrum, it penetrates the buildings, you see it, And you will be having the single digit accuracy that GPS provides, that in open space. It doesn't do it in urban. If you go to open space of GPS, it's beautiful. You're seeing all the satellites and you're seeing because there's no buildings. So we can do that when there's buildings because 900 megahertz propagates, indoors, and the buildings are not a problem for it as much as a satellite.
Yeah, I mean, I know surveyors that use. I used to be a civil engineer in a prior life, that use the GPS system very, very effectively in rural areas. I guess the more satellites you can kind of triangulate to, the more accuracy you can get. So they can get down to like centimeter accuracy in rural areas
Yeah.
with certain equipment. But urban areas, do you have a sense, like in New York, does that decline to maybe 100 meters, and you guys can kind of keep that centimeter accuracy?
100 meters is not very good accuracy. We would definitely go single digits. So think of a number between 1 to 9. And then to your point, when the use case is there and a commercial monetization makes sense, you could actually do more to provide centimeter accuracy, just like high precision GPS, right? It's broad everywhere, certain accuracy, and then in areas like in agriculture, they've actually deployed more to do centimeter. You don't want to do centimeter everywhere because that's of no use. That's a waste of resources. You want to do it where you need it. So can we do centimeter? Absolutely, but we're going to do that based on, what's the rate of return on that extra cost.
So
But
the 1 to 9 you were referring to, is that feet, centimeters, meters? Yeah,
meters.
1 to 9 meters. Okay,
Yeah.
got it.
Yeah, you want to be below 9 for good accuracy.
Okay, got it. And that how much coverage do you think will get built out? I know you're covering over 90% of the country. Do you think the carriers will likely build out the entire country?
The carriers could build out the entire country. They normally add low band propagation spectrum is what gets also deployed in rural areas, right? Nobody deploys C band or mid band in rural areas. So they could deploy that because it's of use. The propagation characteristics make economic sense. So absolutely, they could deploy this. They're definitely deployed in the urban areas where there's a coverage problem, but they can also deploy it in the rural areas and match the footprint of their existing towers for what they have as low band. T-Mobile 600, Verizon, AT&T 700, 850. These have already a footprint that's nationwide.
And I guess worst case scenario, let's say the FCC doesn't grant your spectrum rebanding. What's plan B, if any?
So, we're not, and people ask this question to me, we're not like a drug company where there's a binary outcome for us. Our spectrum is very valuable. It will be put to use, and our technology is also valuable and it will be put to use. We would like to focus on this because that's in our opinion the highest return that solves the national security problem. And we really are confident in this path, but that does not mean that if this path, for very unlikely, doesn't pan out, that all of a sudden we have a binary outcome. That's not our case.
Got it. I mean, you could have some potentially geographic exclusion zones or lower power levels, or you might have to spend some money on upgrading some
Yeah.
existing equipment out there. So there's definitely got it. There are definitely ways to fix this. And so then, lastly, on the valuation front, how did they come up with the 14 billion valuation? And how do you think about the valuation of the spectrum?
Well, the Brattle Group was looking at a GPS loss. That's different. They did not do spectrum valuation. So they looked at how much would it be a loss to the economy and where GPS is used. As far as spectrum valuation for us, we have not put out any numbers. And we actually, if someone's interested in that, they should look at the recent transactions, right? Nobody can put out a number to say, this is what my spectrum's worth. It's all about timing. It's all about the characteristics of the spectrum. And it's very early for us to put a number on this. But recent transactions of low band, whether it's 600 megahertz, whether it's 850 megahertz spectrum, whether it's any other spectrum that is in low band, are good indicators for what low band spectrum's worth.
And what was the average megahertz dollar per megahertz pop on those transactions?
So there was, 600 megahertz has gone as averages of $2.70 that I've seen in some of the transactions. 850 is very hard to say. I think anyone who's looked at that, there's a value associated with the 600 megahertz. There's a value associated with what the cash deal was with this is a grain and T-Mobile, but there's also a return on when the spectrum is sold. So you have to take those, add that, and come up with a number. And I don't want to put any speculative numbers out there, but it's a good low band value, I would say. Um, those will be two good indicators.
Above $1 per megahertz pop anyway at the
Yes,
850, do you
I
think?
would say
Okay.
it's, I think ultimately when with the return to T-Mobile from the sale of the spectrum, this could very well be above $1.
And I guess lastly, you are spending a lot of money on a, monthly, quarterly basis. Is there a way to reduce expenses over the next, couple of years, or what are you kind of, spending, the money on through this process here?
Yeah, we're really a small and mighty team, and we operate very efficiently. We have an existing live network that's monitored 24/7. It's a terrestrial network that's deployed in the US. We have a commercial product that saves lives and by E911 callers on certain handsets of Verizon. We work with FirstNet, so we're not a just this FCC process, which is very important to us. It's not that there's a lot going on in the company. So the towers, the live network, the commercial products, the SLAs that we have, and we do this with very efficiently. So the significant cost that we will have reduces one, no taxpayer dollars and no need to raise billions of dollars to deploy a 5G network. I think that's the best way to look at it. Right now, we're operating very efficiently.
Great job, Mariam. Really appreciate the time, and good luck with the whole process here. We'll talk soon.
Thank you, Tim. It's always a pleasure talking to you. Thank you so much.
Okay, too. Bye bye.
Bye.